Hi, welcome back. And the math puzzle today is this question here. This little guy went shopping and he bought a hoodie and a pair of shoes, and the total cost of these products were $150. If only the hoodie cost $100 more than the pair of shoes, how much does only the shoes will cost? That's the question, that's the math puzzle for today. Just to have a little bit of fun working on solving math problems. At the end of the lesson we will get back, we will work on this question. Now we will work on our lesson, chapter 2, Equations, Inequalities and Problem Solving, section 2.5, Compound Inequalities. The objective number 1 is to find the intersection of two sets, and the solution set of a compound inequality formed with AND is the intersection of the solution sets of two inequalities. So the word, what is interesting here is every time you see the word AND, in math, the word AND will mean intersection. So the intersection of two sets, A and B, that means A intersect B, is the set of all elements common to both sets. And you will remember the Venn diagram, the intersection is this area here in the middle that are common to both sets. Very simple example here, find the intersection of the set 2, 4, 6 and 8 and 3, 4, 5 and 6. We have to find the set of numbers that are that belong to both, that are common to both sets. So we can see here that 4 is common to both, and we can see here that 6 is common to both sets, and that's about it, right? So the intersection, if you want to answer, is going to be this set of numbers that are common, not three. The common numbers are 4 and 6. Okay, this is a very simple example to remember how to work out intersection. And now we will solve compound inequalities containing AND. That means intersection with intersection. Solve and graph the solution for x plus 4 greater than 0 and 4x greater than 0. The first thing we have to do, let's split here the screen, and on this side we're going to work the inequality x plus 4 greater than 0. On this other side we will work the inequality 4x greater than 0. Right? On this side we can apply addition property of inequality and add -4 on both sides. So we will have x greater than -4, right? This is one inequality. The other one, the other side, we can apply multiplication property of inequality and multiply both sides by 1/4. And we simplify and have x greater than 0 times 1/4, 0. Now let's work on our the number line. Let's say here in the middle we have 0 and all the lines. This is going to be the first inequality, the second inequality, and here is going to be the first intersection with the second. Okay, First inequality that we have, x greater than -4. So draw here, let's say -4 is here, -4. If x is greater than -4, everything that's on the right hand side of 4 is included, but -4 is not included. We don't have an equal sign here, see? So -4 is not included, but everything else on the right hand side is included. Now let's check the inequality number 2. This one. X is greater than 0. Represent here. X greater than 0. Everything to the right hand side of 0 is included, but 0 is not included. We want the intersection. The number 1 here, intersection with number 2. So we need to find the set of numbers that are common to both. So this side here, from 0 up, is all common to both, right? Both have this set of numbers on the right hand side of 0, greater than 0. 0 is included here, but not included on this set. So we will represent it with this parenthesis, that means 0 is not included. And everything less than 0, it shows up only on the first one, not on the second one. So we're not including because it's not common to both. This is the result. And we can represent using interval notation. Is from 0 to positive infinity or just infinity. Okay, now we have another example. And there's a step-by-step here by the sides so you can follow. Solve 0 is less than or equal to 4 times parenthesis 5 minus x, which is less than 8. First step, apply the distributive property. And then we will have 0 is less or equal than 4 times 5, 20. And 4 times negative x, negative 4x, less than 8. Now subtract 20 from each side. This is addition property. Subtract 20, and we have three sides here, 3 parts here, right? So we have to subtract 20 from all. That's the result is going to be negative 20 is less or equal than negative 4x less than 8 minus 20, negative 12. Now divide each part by negative 4. We're going to divide by negative 4 or multiply by negative 1 over 4. Multiply each part by negative 1 over 4. Let me see, this is negative 4, negative 4, negative 4. And we will find here negative with negative positive, 20 divided by 4, 5. Negative 4 with negative 4, 1, so x. Negative 12 divided by negative 4, 3. Remember, if we divide by a negative number or multiply by a negative number on any inequality, we have to flip the inequality sign. So flip all the inequality signs. The result is this. And we can write like this, or we can write like this. 3 less than x less or equal than 5. And we can represent this result here using the number line, and it's going to be an interval between 3 and 5, right? 3 is not included, and everything between 3 and 5 is included, and 5 also is included because we have an equal sign. And another way of representing is using interval notation. Parentheses 3, comma 5, bracket, because the 3 is not included, but 5 is included in the interval, in the solution. Okay, next example. Now we have here 2 less than 4 minus x less than 7. And let's simplify. We will apply on all the parts the addition property. So subtract or add -4. I like to say add -4 on all the sides. So you will have -2 less than, and this will simplify, -x less than 3. And now multiply everything, every part by -1. Multiply by -1 here, multiply by -1, and multiply by -1. Let me squeeze here, -1. Yeah, you get it, right? Multiply by -1, all the parts. Remember, when you multiply, you have to flip the equality sign, the inequality sign. So 2, -1 times -2, 2, x, -3. Okay? If you want to represent this using the number line, so find here the number line. Let's say this is 0, this is going to be -3, and let's say this is 2, right? The interval between 3 and 2 is included. Everything here in the middle, the interval is included. 2, we don't have equal sign, that means 2 is not included. We don't have equal sign here, that means 3 is not included. We also can represent the solution using interval notation, which is going to be -3 and 2 within parentheses. All right, moving to the next objective, finding the union of two sets. We worked before with intersection, now we will work with union. The solution set of a compound inequality formed with OR is the union of the individual solution sets. In the same way that AND means intersection, OR means union. Every time you see the word OR in a question like that, you will understand this means union. And the union of two sets, A and B, is the set of all elements that belong to either of the sets. A union B is denoted by A. This looks like a capital U, B, right? It's the whole thing. The union is just the whole area, everything that belongs to A or belongs to B. Simple example to remember. The union of these two sets is going to be all the sets. You can say 2 and 4 and 5 and 6, right? And 8. All the sets that are here, all the numbers I mean that are here on this set, all the numbers that are here on this other set, they all belong to either one. That means they are included in the union. And I forgot 3. Sorry. Let's add 3 here. 2 and 3. Sorry. 2, 3, 4, 5, 6. You don't have 7, 8. Great. Objective 4. Solve compound inequalities containing OR Oops. And check this example here. Solve 5 times parenthesis x minus 1 close parenthesis greater or equal than negative 5, or 5 minus x is less than 11. And what you're going to do, that's a split, the same thing we've done before, split in 2 screens, and we have here 5x minus 1 greater or equal to negative 5. On the other side, 5 minus x less than 11. And we will simplify each inequality. Here we have to apply distributive property, and this will be 5x minus 5 greater or equal to negative 5, right? You can apply now addition property, add 5 on both sides, and then we will have 5x, cancel 5x greater or equal to 0. If you divide both sides by 5, since here on this the right hand side you have 0, you end up having x greater or equal than 0, right? And on the other side, simplify. We will apply addition property again, subtracting 5, adding negative 5 on both sides, you might say. So negative x is less than 11 minus 5, 6, right? We can multiply both sides by negative 1. Remember, just remember, always, when you multiply by a negative number or when you divide by a negative number, you have to flip the inequality. So as a result, you're going to have positive x greater than negative 6. Now represent, let's use the number line, right? Let's use the number line. And the first one, let's say this is number 1, this is number 2. X greater or equal than 0, say 0 is here, 0 is here. Then the first one, x is greater or equal, greater than or equal to 0, right? So bracket, because we have an equal sign, 0 is included, and everything greater is also included, all the way to infinity. Now let me use a different color here for number 2. Number 2. 2 is going to be x greater than negative 6. Let's say negative 6 is here. We don't have an equal sign, but everything greater than 6 is included. Everything greater than 6 is included, right? Nice. The result, 1 union, and let me use a different color here, purple. 1 union 2 is going to be everything that belongs to either one. The set, the first set, the second set, this is going to be included. So it starts here. 6 is not included, nor here nor here. So 6 is not included, but it's the limit. We will represent here negative 6, and this part is included in one set, and this part here, this set, is included in both. So the union is going to be this last line here, as you can see. The set of number that is included in either one or the other set, you put together and define the union. This is the last example, and let's again split the screen in two, and then we work with negative 2x minus 5 less than negative 3 on this side, and 6x less than 0 on the other side. Simplifying on the left hand side, we can apply addition property, add 5 on both sides, and then we can simplify, have here negative 2x less than negative 3 plus 5, 2. And divide both sides by negative 2. When we divide by a negative number, what should we do? If we are dividing by a negative number, we have 2 divided by negative 2, negative 1. We need to switch or flip the inequality sign, right? On the other side, it's kind of, yes, we just can apply multiplication property of inequality, dividing both sides by 6. And since this is 0, the result is going to be x less than 0. We are working on union. So this, let's say, is number 1. This is number 2. Number 1 is going to be x greater than negative 1. Let's say here is 0. Here is negative 1, right? X is greater than negative 1. Everything that's on the right hand side of negative 1 is included. Everything on the right hand side is greater than negative 1. The other one, x, the number 2, the equality number 2, x is less than 0. So 0 is here, x is less than 0. Do using the red, and everything to the left hand side of 0 is included. Is that okay? Right. We are working on union. Remember, the word for union is or. Everything, every number or line or anything that you see here that have color blue or have color red is going to is included, is in. So everything that have color blue or color red. So check the first here, this negative 1. Negative 1 is not included here, but yes, it's here. So negative 1 is everything that's greater than negative 1 is, and everything that's less than negative 1 also is included, because it belongs to one, to the other, or to both. Doesn't matter. This is the solution. This last line represents the union of inequality 1 and inequality 2. And the whole solution, if you represent using interval notation, is from negative infinity to infinity. Okay, this is the end of section 2.5. And did you find the answer for this this math puzzle? The total cost of a pair of shoes and a hoodie is $150. The hoodie costs $100 more than the pair of shoes. How much does the shoe cost? The automatic answer, I gotta tell you, is going to be the wrong answer. When you read this, is 50. Most of you say, oh, the shoes will cost $50, right? Yes, this is the right answer. But no, this is the tricky answer, the wrong answer, the trap. To find out, you're gonna write down a very simple system of linear equations. The price of the hoodie plus the price of the shoe is $150. the price of the hoodie less minus the price of the shoe is 100. And you're gonna find out that the hoodie, if you solve this, you're gonna find that only the hoodie costs $125, and the shoe will cost. That means that the shoes alone will cost $25. That's the solution of the puzzle. Thank you for watching, and see you on the next section.